In the last video, we saw that we wrote a program to calculate Fibonacci for using recursion. In this one, we are going to see what memoizing is and how to implement it with Fibonacci and why to implement it with Fibonacci. We need to implement memoization with Fibonacci because Fibonacci with recursion for large numbers is almost impossible with your machine, regular machines, right? Because it takes a lot of computation, and to reduce that, we use something like a memoization. So memoization is basically uh, storing the answers to questions that you have already solved and using it, reusing it. So if something is already calculated, just store it somewhere and use it to whenever that question arises, right? That problem arises, use that value, use that answer directly without calculating. So reducing the calculations. So how are we going to use it in Fibonacci? Let's look into that. So this is the program that we saw. Let's write a new program now. We'll continue with this itself, and we'll add memoization into it. How to do that? It's very simple. Paste our existing code here of recursion, use calculating Fibonacci using recursion, right? And write another function called solution. Solution takes in num. Okay, inside of num, we'll just do some. We'll add the memoization. So const map is equal to, this is a map, hash map, or dictionary or object that I'll maintain, which will store in key values for all the values that are already calculated, right? So in this recursion, say n minus 1 is calculated once, right? Or n minus 2, Fibonacci of n minus 2 is already calculated once. So for that, we will store the value in here, and anytime the program in some other areas, in some other depth, wants to calculate it again, it will just fetch it from the map and see it, right? So this recursion function, we're going to call it after initiating the map. Inside the recursion function, I'll just add I'll first of all call this recursion function from here. Okay, so that is done. Now I need to store values in the map. When do we store values in the map? Once we get a value, right? So map dot map for num, we will store recursion of 1, which is the Fibonacci. This is actually getting me back values of Fibonacci, this recursion function, right? Similarly, I'll do it for 2 as well. No, I need not do it like this. What I can do is I can immediately store this entire thing. I'll store as map num equal to this, right? And I'll return map num. Okay, and before calling this, I'll just check if it's already there in map. If map.num exists, I'll simply return whatever the value is stored, map.num, right? So here I'm storing the value, and second time if I'm going there, I already have the value. I need not compute all of these three. I return from here itself, right? So that is my memoization working perfectly. Let me try and run this 37 recursion of 37. This won't work because I need to change the function name. It's now solution. Okay, let's call this. It's returning undefined because I haven't returned from here. So I return recursion now, and there it is. Instantly it was able to calculate the Fibonacci of 37. Let me try 50, a bigger number. Instantly, such a big number as a result, and it was able to return the value very quickly. That is all because of our map, right? That is all because of memoization this way, right? These three statements. One is these, okay. One is this, and one is this. So 3 instantiates the map. 2 checks if the value is already there in the map, it uses it, it returns it, and 1 where it adds value to the map if it is calculated for the first time, right? These 3 simple steps adds memoization to your recursive function and reduces the increases the performance, reduces the time it takes for your program to calculate, reduces the overall calculation of your program, and allows you to calculate something like Fibonacci for large numbers. You can now go in for 100 as well without any issue, right? So that's it. See you in the next one.